So let's go through the graph. As I told you, when you're looking at calls and puts, start here and work to the right. When you're starting here, work to the left. So let's start off here at 80. 80 has got something going on. 75 has something going on. 30 has something going on. And 0 has not much going on. And then 90 has something going on. And 100 has something going on. Yes?
Do you care about the scale as far as proximity? Like if I just drew it?
Not too care. I'm mainly interested that you know what's going on.
Should we specify the 0?
Huh?
Should we specify the 0?
Yeah, I'm not worrying about the cost of the options. Well, I'll show you what to do with the cost of the options. Much of what we're going to do in this course is to figure out what is the price of the options. That's the Blac-Scholes. All righty. So what happens then is we're starting here at 80. My call is useless until I get to 80. When I get to 80, it's going to have a slope of 2. It's going to have a slope of 2. And it'll have a slope of 2 forever. Except I'm going to start losing money once it's 90. So when I get to 91, I'm going to get, from 90 to 91, I'm going to get $2 here, and I'm going to lose $1 here. So the slope is now going to start being 1. And when I get to 100, I'm losing another $1. And so the slope is going to be 0. Okay? Everybody with me on that? Now going the other direction, this portfolio right here is 0 for anything greater than 75. But at 75, it's going to start increasing with slope 1, or actually slope minus 1. If you have 1, we'll call it right. And then here I'm starting to lose, and so I'm going to have slope 0. And so there's your portfolio. Okay? How many got it right? Okay, very good. Excellent. Pardon?
Do you need to draw like the premium graph?
No, just what I have there is enough. I mean, what I did yesterday is showed yesterday, meaning Tuesday, is I showed you all the others. If we can figure out what the premium is and what the costs are, then it's going to look like this. So be careful to read what I'm asking on a quiz or on a test. And this one I said, ignore the cost. Yeah?
So this is what we talked about in class, but
Yeah.
if you actually drew the puts to extend through infinity, wouldn't they affect the calls as well? Because that's sloping down from...
No, it's got 0 slope. That's a straight line. That's a straight line.
Your negative 30 call, your negative 30 put, sorry,
Yeah?
goes downward forever?
No, it doesn't. For anything more than $30, what has happened? It's going to be ignored.
But why?
Remember what a put is. For $30, oh, here's 75. Here's 75 right here.
Yeah, that one makes sense.
And then the negative 75 is just going to be taking this curve right here and flipping it. And going down here. Doesn't affect anything over here. It will with the option, you know, the amount of money you paid for it, but that's it. Okay? All righty. I told you that one of the things which you will learn here is how to create your own options, your own portfolio. So let's do that. Let's now suppose that what we have is the following curve minus the options, I mean the cost of the options. I want my curve at 70 to go up with the slope of 3. I want it at 80 to go over with the slope of 0. I want it then to go down at 90 with a slope of -3. And I want it to be 0 for thereafter. And here I want it at 60 to go up with the slope of -2 until I get to 40. And then I want it to be 0. Create the portfolio only using puts. Only using puts. So I have slope 0, slope -2, slope 0, slope 3, slope 0, slope -3, and slope 0.
Hit slope 0 at 100, right?
Bigger pardon?
Let's hit slope 0 at 100.
Yeah, this is 0, 0, 0, 0.
Oh, is that 100 right there?
This right here is -3.
No, like, oh,
So I'll read them off again. 0, -2, 0, 3, 0, -3, 0. The slopes.
like an option price after you.
Oh, never mind the option price.
Oh, not near.
Yeah, we're not talking about that yet. We're going to start. Yeah.
Strike price after the 90?
After the, oh, I see what you're asking. Yeah, what is this number right here? That's let's see, that's 10, so that's 100. I see, thank you. I would say that I'm sorry, but that would be a bad pun. Yeah, let's get to work on this and see what we're going to do. If you're using only puts, you have to start far out and start working to the left. So I'm going to be going along here, and I want to go up by 3. What do I need to do that? I need 3 puts at 100. Next, what I want to do is I need to flatten out. This is going to continue to give me $3, so I have to find a way of subtracting off $3. That's going to be minus 3 puts at 90. Now I'm going to come along and I'm going to get to 80. At 80, I want to go down at the slope of 3. I want to start losing money, so I want to go minus 3 puts at 70. No, 80. Next, so where I am, when I get to 70, I want to flatten out. So right here, I'm losing $3, so I got to gain $3. So I add 3 puts at 70. Now I'm going to flatten out. Now, I want to go up with a slope of 2, start making money. So I'm going to start adding 2 puts at 60. When I get to 40, I want to flatten out again. So I want to subtract 2 puts at 40. And there's my portfolio. Yes,
Does it matter which way you started off?
yes. So you asked, does it matter which way? If you try to start for puts from the left and work to the right, it's going to be confusing.
But is it doable though?
Oh, it's doable.
Oh, so it's okay if I can get it?
It's just, look, I tried it that way, and look at my hairline. That's why I do it the other way now. I'm trying to save what little's left. Okay. So that's what we have here. All righty? Any questions on this? All righty, folks. Now do it with only calls. If I want to do this only using calls, I start from the extreme left and work my way to the right. This right here is everything's fine until I get here. I want to go down 2. So I want to have minus 2 calls at 40. To have a slope down here. Everybody with me on that? Now I want to flatten out, so I better buy 2 calls at 60. Flattens out, I want to go up 3, so I want to buy 3 calls at 70. Now what I'm doing is I'm going up at 3. I want to flatten out. And so I want to sell 3 calls minus 3 calls at 80. I want to go down. And so what I'm going to go down here is I want to have minus 3 calls at 90. And to flatten off, I'm going to add 3 calls at 100. Everybody with me on that? Notice anything? Notice, yes. The equations are the same, aren't they? Calls and puts, they're essentially the same. See, one of them, I did this purposely right by each other. I have either minus 2 puts at 40, minus 2 calls to here, 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 here. They're all the same. Shouldn't be a surprise because you're just going up at 45 degrees or coming down at 45 degrees. And you're going to have the same thing. And one going to the left, one going to the right, so that flips everything again. So now, what do you think would be the portfolio if the current price is 65 and I want to do calls this way and puts this way? Yeah.
So what I don't understand is how do we know if it starts from the where x is 0?
Oh, yeah, you're asking where x is equal to 0. We don't. We have to find out what the cost of the options, and we're going to go into that very next.
So, well, what I'm saying is, say we were just given the equation using only calls and had to figure out the graph based on the portfolio, the calls.
Mm-hmm.
So if we're starting from 40, the strike price is 40, how do we know that we're going to start on the
We don't.
x-axis?
We don't.
Down to
We don't.
this starting?
We don't. So he's asking a very good question. He's saying that, look, what you did is you drew the profit curve. You didn't throw in reality. You didn't throw in the cost of the options. Because if I threw in the cost of the options, everything would be lowered or raised. And we're going to ignore that until we get, to know how to design portfolios.
From the call
Yeah.
equation, wouldn't the graph shift downward?
Okay, so let's take a look. We're going to see the whole graph would shift downwards for both calls and puts. And we're going to see a little bit how they're going to shift down next. But right here I have a call. Remember what a call is. Call is going to look like that, correct? And so a short call is going to look like this. And so therefore I'm going along here and I want to go down. Yes?
I think we're saying why isn't it starting from the origin?
Oh, starting from 0?
Yes.
Okay, I'm starting from 0 because I said I'm going to use calls. You go as far to the left as you can if you're going to use calls and work to the right.
Not on the x-axis, like the y-axis.
Yeah.
Why does it not start from 0?
Oh, it could. You could have it down there if you
Because
want.
like if you're just looking at the call, like the portfolio
Yeah.
for the call, you don't
Sure.
know.
Like
Sure.
why intersect?
Yeah, you see what she's saying is she's saying, look, 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 look. How did you raise it up there? What she says is she wants her curve to look like this. Correct?
Yeah.
Yeah, that's fine. We'll worry about how you raise and lower it later when we get the price of the options. Right now, I just want to use the geometry to figure out how to put in calls and puts. All right? Good question. Anyone else? All right, so how would you write to get a graph of this type right here? Using calls over this way and puts over this way. What do you think, just looking at what you got here? Yeah, so what you're going to do is right here, we're going to have put, call, call, call. And that would be the equation. Now, we're going to do next is we're going to start talking about how much does a call cost. All righty. Got two calls. One with the strike price of 60, the other with a strike price of 70. Which one do you think is more expensive? Huh?
70.
70, why? Bigger number, huh? All right. What about you? What do you think? 70, why?
The strike price is 70.
Yeah, strike price is 70, so you think the option would cost more? So what happens is you're selling these options. Which one are you going to charge more for, C60 or C70?
70?
Okay, she says 70, and you say what?
60.
Why? You're in a disagreement. We'll get you up in the front and let you go after each other. Go ahead.
Okay, because the call when you exercise the call option at 60, you're making money if the price goes over the strike price. So,
Uh-huh.
So when the strike price is 60, you're more likely to make money from the option.
Okay, you going to argue against him? Okay,
It's a trick question. It depends on what the stock is currently selling for.
doesn't matter.
Yeah, it does. If it's closer to what it's selling for, they'll sell it for more. So if the price of the stock's $59,
Mm-hmm.
then your call at 60 is going to cost more than your call at 70.
$69? No.
59.
No.
Yeah.
What happens is, anybody else got a comment? Yes.
It depends on how the stock will go. Will it go
So you two are in agreement. Okay? You're saying it depends on how the stock's going to go. Okay?
depends on the probability that it will go up.
The probabilities it's going to go up and down. Correct.
I would say 60 because, for example, if you're selling the call, then you think it's going to go up. So, for example, if the price right now is 55, you think it's going to go up. If it goes up to 65, then the other person will exercise it. and that's more likely than going up to like 75, because that's a bigger
Okay.
range.
Interesting comment?
So if it's 60, I exercise the right to buy it at 60. If it's 70, I exercise the right to buy it at 70. So wouldn't I want to buy it at the lower price?
Yeah, you would want to buy, but remember, you're selling them to me, the options. Yeah,
What is the current price of the stock?
say 55.
Okay, then 60 is gonna be, or, oh. In that case, I'll get back to
All right.
Who
What?
has the option to buy? You have the option to buy? Or
Remember, a call is you're allowed to call someone and say, hey, I want to buy
am I
that.
buying the call from you? Or?
Yeah, no, you're selling it to me. And I want to know which one you're going to price higher.
Okay.
Which one are you?
60?
60, why?
Because no matter what, I think I make $10 more. Or it's easier for you to make money off the 60.
Okay?
Because you lose more when the price go higher, and then when you 60, it's easier to lose.
Excellent comments all the way around. So let's take a look and see what it is. You are selling these two options. And what you want to do is you want to find out, when am I going to get hurt? If I'm going to get hurt earlier, I want to make a charge more. So what happens is, on March 14th, see, we're charging these now. At March 14th, if the price of the stock goes over 60, I'm going to start losing money. Remember, I'm going short. So therefore, the curve is, for me, going short. This one is 60. Everything is fine till I get to 60, then I start losing money. The other one, the option is until I get to 70, and then I start losing money. Okay? And so what happens then is, I'm going to start losing money at a lower stock price here. And since I'm going to start losing money, I'm going to charge more for it, because I'm obligating myself at an earlier stage. So therefore, what I would like to do is I would like to charge more, so when I get the charge, that my curve will look like this. Here, I will charge a little bit less, so my curve looks like that. So what you do, the price of an option, if you're selling the option, the price, which is larger than the other, is going to be determined by, when are you going to get hurt? When are you going to start losing money? When you're going to start losing money, you want to charge more. Okay, everybody with me on that? Who's not? Okay, you're not. All right. So now what I want to do is, so we now know the following. We now know the following, that if you have, that the cost of CE1 is greater than CE2 if E1 is greater than E2, or wait a minute, smaller than E2. Because you're starting to incur cost earlier. What about puts? So suppose I have a put. Which one's going to cost more? 70 is going to cost more because you're going to start losing money quicker. And so you have the intuition on how to handle it. Any questions? All righty. Let's now get into a very important equation. And I'm going to get all except for one term. A very important equation on the cost of options. This is an equation we're going to use throughout, and I'm not going to be, I might be able to drive it today. Yeah, I might be able to. And what it is it relates cost of puts, calls, stock, and time. Relates all of them. So I'll write down part of the equation now, and then we'll get the last part. We'll start there. It is the price of the stock today, right now, at this instant, plus the put, the cost of the put at this instant, is going to equal the cost of the call at this instant, plus, I'm going to write down something and then we'll just find out what this means in a few minutes, plus E, strike price, exponential to the minus R T minus T. What in the heck is that? Where did all that come from? And what's R? R is the current interest rate. Current interest rate at the bank. And the question is, where in the world did that come from? Okay. So this is the put-call parity equation. It is a put, and on this side makes sense. I have a put, and I can sell this, and here I've got the item to sell. Here I have a call, and I have the money to buy it. So that there has to be an equation between these two. And so this right here is going to correspond to money. What we're going to have to do now is figure out what in the world does this mean, and where did it come from out of the sky? Okay. Where it comes from starts in 4th grade. In 4th grade, when you finally got decimals, do you get decimals in 4th grade? I don't remember. When do you get decimals? 5th grade? 4th grade? 3rd grade? Kindergarten? In very advanced kindergartens, you probably multiply with decimals. Okay? Now, what you do is you had the problem. You have $100 in the bank. Interest rate is equal to 0.03. In 1 year, how much money do you have? Kindergarten 101. Okay? And you know what that is. You take the amount of money, you multiply times the interest rate, multiply by time, which is 1 year, and this is equal to your new money. That's what you get. All right, big deal. Suppose you have it for half a year. What do? No big deal. You change the 1 to a half. No big deal. Suppose now we're going to compound the interest continuously. And so the question is, what happens now? It's really the same problem. Nothing changes. Nothing changes. It is the change in my money is the interest rate times money times time. What we did in the first problem is we said this was 1 year, money, interest rate, change in my money. If we said a half a year, we put 1 half year, dum, dum, dum. If I do it in delta t seconds, every 5 seconds, that's the equation I'll have, or I'll have 5 seconds over a year, or what portion of a year is 5 seconds, and I would have that. Or what this says is that the change in my money over the amount of money I have right here is clearly, that's going to be the interest times the amount of time that's elapsed. Okay, no big deal. Everything here is straightforward. And then the next statement is, let's just add everything up. And I have that equation. No big deal. What happens is, this is an approximation. What happens is the best approximation is we just let the time get smaller and smaller. And what we end up with then is the problem of the integral. That smooths out this S, it smooths out that D. The integral of d money over money is equal to the integral over r dt. Okay? And so now all you do is you substitute information you have and where you need to substitute it in, play games, and away you're done. Of course, you don't remember how to integrate that. So let me remind you how to integrate this. The integral of d anything over anything is equal to the log of that anything plus c, otherwise you lose 2 points. Ever since Newton was discovered calculus, you lose 2 points if you forget to put down the c. Alrighty, no big deal. That means that anything I put in here, you get this. So I have that the integral of d cabin over cabin is a log cabin. Okay, so whatever you put in there, that's what you're going to get back. All right? So who doesn't remember logs? Who doesn't remember logs but doesn't dare raise their hand? All right. So what happens then is I'll give you just a real quick statement of logs. Logarithms are chosen so that this integral is going to be just this log right here. But what happens is a log, I'll do logs in a few seconds, so let me go ahead and get this.
What's the question? The question. What's your question now?
We'll get to your question down here in a second. So whatever information you put here, you're going to be able to integrate this. So let's do the following. I want to know my money right now. How much money do I have to put in the bank right now to get E dollars a little later on? So I'm going to the bank, and what you're doing is you're trying to save money so that on spring vacation you can go to Hawaii. She's in total agreement, okay? And you can take a look and see how much it costs to go to Hawaii. E dollars. So you have to know, how much money do I have to put into the bank right now? I know the interest rate. How much do I have to put in now so that I'll have E dollars so I can buy that ticket to Hawaii? Okay? And so let's see, you put in the information. Here's the amount of money I have. Here's time today. Here's expiration date. Here's time March 14th when you're heading for Hawaii. So when you just have that equation, you just put down the limits, what information you need. At time t, that's how much money I have. At time t, that's how much money I want to have. And so what we end up with then is that The integral is going to be the natural log of m evaluated between the amount of money I have today and E dollars a little later on. Equals R E minus T from integrating. Okay? Everybody with me? Now all we have to do is get rid of the natural, what this is going to be right here, is this is going to be equal to the natural log of E minus the natural log of the amount of money I'm going to put in the bank today. Yep.
I thought that the
You're right. You're right. I had T over there. You're right. Thank you. We'll get a better equation with your correction. Okay. Thank you. So that's what we have here. Okay. Everybody with me? Now and this right here then is going to be the natural log of E over the amount of money I have today is equal to R T minus T. And you remember how to get rid of natural logs? To get rid of natural logs, I raise these as the power. That'll be E to the natural log of E over MT is the same thing as E to the R T minus T. So I have that equation there. Everybody with me? If you're not, let me know, and we'll go back, or we'll review some of the natural logs and E's and stuff. You don't remember that, right? You do remember it. Good. Whew. Okay. So now what happens is, remember the relationship between E and natural log. E to the natural log of anything equals anything. So what I have is that this is equal to E over the amount of money. Remember, I'm trying to solve for the amount of money. So I'm going to invert this. I have to invert that. So when I do that, I have that the amount of money today is E to the minus R T minus T. The minus came from inverting this so I could solve for that. Look familiar? It's precisely the equation we have in the put-call parity equation. Okay, everybody with me? Yes?
What is small t?
It's time today. So what this says then, it's that capital T is March 14th at noon. So it says that today, that $100 today, $100 at this interest rate on March 14th, today it's worth this amount of money. Present value of money. Present value of money. Question?
Does this term factor in that much now since interest rate's like almost zero?
Oh, you mean the interest rate's so low? Yeah, right now it's, but it's still there because you still can borrow money from the bank and you still can loan it, and it's going to play a role, a very important role in all of this. The fact that this is almost equal to zero means that's 1, and it means that my put-call parity is this equation nevertheless. Okay, everybody with me? So what that is then is an important equation for the present value of money. Do not memorize it. There's more important things to memorize. Like, there's a basketball game tonight at 7. That the weather outside is gorgeous and what am I doing in class? Like all sorts of important things. Don't clog your mind with, it's so easy to derive. Number one. Number two, the reason is I'm going to give you problems where if you memorize it, you won't be able to do the problems. But if you go ahead and do it like this, you're done. It's no problem. Problem. I put my money in the bank. Just put it in the bank and let it sit when it's compounded continuously. And you know what? In 5 years, I doubled my money. What's the interest rate? Go ahead, try to figure that out. 5 years. I put money in the bank, and in 5 years from now, my money has doubled.
You're asking the annual return?
I want to know what is the interest rate that's being compounded continuously, yes. So I want to find the value of R. The way you solve that problem is you just go to the integral, put in the information you have. D money over money. I have a certain amount of money. I didn't tell you how much I put in the bank. I put in a certain amount in. And all I know, and when did I put it in? I put it in today. 0, today. R dt. And in 5 years, I got twice as much money back. You have one equation, one unknown, R. Solve for R. And so what I have here is I'm going to have the natural log of 2m star over m star is equal to 5r. And the m stars cross out, and so I have that the interest rate is 1/5 the natural log of 2. And I have my answer. Yep.
So isn't this just principle, the PERT equation we've always used? Do we need to derive it
Yes.
with integrals, or can we
Yes.
just use the equation?
No, you got to have to derive it. And the reason is that in finance, you're going to be getting all sorts of equations that are different than this one. For example, I may have an equation where what you're doing is you have money in the bank, but your grandfather is sending a certain amount of money on a continuous basis into your account. That equation no longer holds. But what I have is, I have the following equation. The change of money is R m delta t plus alpha delta t, the amount coming in from your grandfather. Now you have a different equation. If you just know how to do the equation, you're nailed. And remember what the goal here is. The goal here is to make sure that you are successful, that when you see a different modification, you don't have to say, oh, what is that formula? You can say, I'll derive the formula. You're a step ahead, and that's what we want to do here. Okay? Any questions on this? You'll have several problems to work out of exactly the type that I just got through telling you. Okay, folks, time for the put-call parity. The put-call parity equation is this one right here. It says that there is an equality. There is an equality that if you look at the market and you look at and see how much a put for a stock costs, the value of the stock, the call, and the present value of the strike price. This is the present value of the strike price. This is the present value of E. How much E is worth today? The strike price is $75. Then today, you know, if its strike price is $75 on when? On March 14th, not worth $75 today. It's a little bit less. It's the amount I'd have to put into the bank. And what it says is that this right here, that this equation relates the cost of this put, the cost of the call, the current price, and the current value of the strike price money. It relates them all into an equality. Now, for mathematicians, this is going to be an unusual way of proving it. You prove it with greed. Okay? In other words, arbitrage. So let's see how we're going to do that. First, let's take a look at what happens at time t. I want you to show that at time t, that's an equality. Go ahead. At time t, at expiration date, that is an equality. So at time t, what I have is S plus my put, the strike price, equals the call, S plus E. Precisely E, because at time t, this is equal to 1. Now what we can do is we can substitute in. This right here is the maximum of 0 and E minus S. And I want to see, does this equal the maximum of 0 and S minus E plus E? All I'm doing is writing down maximums for the put and the call, exactly what the put and call are, you know, that curve that we've been discussing. Okay, let's take a look and see what happens. Suppose S is less than, if S is less than E, if S is less than E, what you going to do with your call? Nothing. Ignore it. Yeah. So if S is less than E, my call is going to equal 0. Will be 0, and I'll have E dollars here. On the left-hand side, I'll have S plus P of E of S. What's going to happen here?
It gets exercised.
I'm going to exercise it. What am I going to do? You're right, just continue.
A profit minus.
Okay, so what I'm going to do is I'm going to exercise it. So what I'm going to do here is I'm going to sell this stock right here for E dollars. So I'm going to have E equals E. Okay, everybody with me on that? Let's go through that again. If S is less than E, if S is less than E, suppose E is $100 and S is equal to 90. On the right-hand side, this is 100. I'm not going to use this at all. That's going to be 0. This is going to be, this one right here is I have the right to sell that stock right there. For this $90 stock, I have the right to sell it for 100. I sell it, I get the 100, and I have 100 is equal to 100. If S is greater than E, what do I have? That means I'm going to ignore my put, because if S is larger than E, I'm not going to put it on something valuable on sale for a lower price. So this will be 0. And so what I'm going to have is S plus 0, that'll be that equation right there, equals the call okay, what do we do here now? Well, what I'm going to do now is I'm going to want to buy it for E dollars, even though it's worth more. I can get it for E dollars. And so what I'm going to do is we put this in here, and remember what we have. This is equal to S minus E is the value of this right here, plus E. The two E's cancel, and I have S equals S. So both sides are equal. Both sides are equal. The amount of profit I'll make is S minus E. I've got E dollars from the bank. The E's cancel out, and I have S equals S. Okay? Now, let's go through why this is an equality. What we have is, suppose today that S plus PE of S is greater than the call E S plus E e to the minus R T minus T. So remember, that's today. What is today? January 16th. January 16th, and their strike date is March 14th. And so suppose today, for example, suppose that this right here is 100. Suppose this right here costs 30. Suppose this right here costs 40. And this right here was 100. How are you going to make money? Arbitrage. How are you going to make money? What I have is, I've got this situation right here. How are you going to make money off of it? Anyone know how to make money? Yeah, you sell high, buy low, right? Or something like that. So what you do is, I don't have any money or anything, but what I'm going to do is I'm going to go to my agent and I'm going to go short. I'm going to go short. That means I'm going to sell the stock. I got to replace it, but I sell the stock. And I sell a put. So I got $140 in my pocket. What am I going to do with it? What I'm going to do is I'm going to take $10, keep it in my pocket, and take a little less than 130, put it in the bank, and buy a call. Okay? Everybody with me on that? Who's not? Okay? So what happens is, you know that at time t, just by writing down the equation, that equation right here has to be satisfied, doesn't it? Because we just substitute in. What I'm doing is I'm saying at some time today, which is t smaller than t, I find out that the left-hand side is larger than the right-hand side. I'm just using some numbers to make it more specific. The price of the stock today is 100. It's right at strike price. The price of the put is 40 for 100. The price of a call is 30. And here's how much money, you know, the present value of $100. I just look and see which one's larger. Which one's larger? So I'm going to sell it. I don't own it, but I'm going to sell it. Okay. So I'm going to go short on the stock. I'm going to sell a put. I'm going to go short on a put. That means I'm going to get $140. I'm going to take 130 of it, a little less than 130 of it, to buy a call and put money in the bank. And I'm going to take the other $10 and go to In-N-Out and have some hamburgers. So I got $10 extra. Okay? Now, what's going to happen at expiration date?
They converge.
At expiration date, they're equal. At expiration date, they are equal. So since they're equal at expiration date, the money I get from here, from the bank, and from the value of this call is going to be sufficient to take care of the put that I went short on and the stock, no matter what its price. Okay? Got a couple of, I don't dare raise my hand looks. Okay. You see where that is then? So at expiration date, this side is going to equal this side, except I have $10 extra in my pocket. So what's going to happen? Everybody's going to try to go short. That's going to drive that price down and drive that price down. And you're going to get convergence. So that what we have there is arbitrage. So let's go through that again, and I'll just give you a couple of problems on your homework to make sure we have it. Yeah.
How did you determine that it was greater? Did you?
I looked in the newspaper, Wall Street Journal,
Okay.
and I saw, actually, if you look at the Wall Street Journal or look at Chicago Tribune, they don't have it in the LAX, but if you look in the financial pages of just on the internet nowadays, and you look at the price of a put, the price of a call, the price of the stock or whatever it is, and the present value of money, you find that they are not equal, but they're very close to equal. Why aren't they equal? You got transition costs. But they're very close to being equal. And the reason they're very close to being equal is that when you look at the newspaper and you find out that the price of the stock and the price of the put, for example, is much larger than this, then what I will do is go short on this. If I go short on this, I take the money and put it over here. And I take the extra money and put it in my pocket. At expiration date, that's what I've got. And I can cash that in to take care of this right over here, my debts. But I also have that $10 extra in my pocket. So I'm ahead. The other way around, if the inequality goes the other way, then what I'm going to do here is sell this. That is borrow money from the bank and go short, buy this. At expiration date, they're going to be there, and I keep the extra money. Because there are a lot of really clever people out there, other people are going to notice this too. And so that means a lot of them are going to go short on their one side or the other. That means that the prices are either going to go down or go up, and you're going to get equality. And that's why we have equality. It's arbitrage. Arbitrage is what gives you equality. Okay? So what I will do is on the homework, let me just give you a couple of things and then we'll leave. Homework. I'm going to give you some homework on exactly this arbitrage type problem. Your homework will be the last two problems, or a couple problems at the end of chapter 2. And I'll give you some extra ones to make sure you understand this arbitrage argument, which is important. What I will do is next week I'll start having extra sessions. An extra session, I'll announce it by email, where and when. And as you might guess, we're getting pretty close to a test. We're getting pretty close to a test. And well, it will not be, what day is today, Tuesday? Thursday.
Yeah.
It will not be next Thursday. Or Tuesday on there. Anybody have any questions? No questions? Go out and enjoy the sun.